There's one more basic language structure that we need to understand so that we can start talking about writing some code. Methods make writing code easier. A method is a section of code that has been given a name, and you've already seen one, the main method. When we tell the Java virtual machine to run our code, it looks for a special method named main that looks like this. The stuff in the curly brackets is the code that we've named, so the JVM runs that code. Both of the previous labs just put all of our code in that method. As our systems become more complex, that would get really big and hard to follow. We can write our own methods to make things cleaner and easier. As an example, the main method in stage 2 got really long. We can make it better by creating methods. This method contains the code that was in the main method that was responsible for printing out the results of the experiment. I've pulled it out into a method named printDistances. Because the method is smaller, is named by what it does, and does one thing, it's a lot easier to understand. Once we create that method, we can put code in our main method that says, go run the code I named printDistances, and then come back here. The main method from that lab is now much shorter, and it's easier to tell what it's doing because printDistances describes what's going to happen.
I don't really see how that works. Can you explain that in more detail, please?
Sure, Zumi. Let's start by talking about the sequence of instructions the machine will run. Here is our new method, and the code in the main method around where we use that new method. When we tell the JVM to run the code, it will run the instructions in the main method. It does all of the stuff for the experiment, which I've left out of this for brevity. Then it creates the variable expected count and calculates what that expected count should be. It prints that to the user. Then we see the name of our new method. We say that we are calling printDistances. When the JVM sees that instruction, it will jump to wherever that method is defined. It will execute the code until it gets to the end of those curly brackets, and then it will jump back to where it was and keep executing from the main method, which has no more instructions, so the program will end.
So, we call a method by using its name followed by parentheses. When the JVM sees that instruction, it goes and executes all of the code in that method, and then jumps back to where the call happened and keeps executing from there.
Exactly. We can also give a method information. We can declare a variable in the declaration of the method by putting the variable declaration inside the parentheses. This variable is called a parameter. When we call the method, we put the value we want the parameter to have in the parentheses. We call that value the argument.
So the parameter is the variable in the method declaration, and the argument is the value we give it when we call the method.
Right. So, if we declare a method foo-foo to have an integer parameter named x, like this, we call it like this. When the call executes, the passing of information is kind of like an assignment statement. This will take the argument of 3 and store it in the parameter x. Then the statements in the method execute. When it tries to print out x, it goes and gets its value, which is the 3 we passed into it. So our output will be foo, and then the value of x, which is 3.
As a side note, notice the difference between print and println. Println, which we pronounce printline, will go to the next line when it's finished, but print will not.
Just like the right-hand side of an assignment statement, arguments can be expressions. In this example, we declare y to be an integer and give it the value 3. When we pass y into foo-foo, y will be evaluated, and that 3 will be stored into x. This works just like the assignment statement x gets the value y. When the method executes, it will print out foo3. We can also use any legal expression as an argument. In this call, y plus 5 will be evaluated, getting the value 8, which will be stored into x. Then those print statements will print out foo8. If we try to pass an argument whose type doesn't match the type of the parameter, the compiler will give us a syntax error if it can't make the conversion. In this case, we tried to pass a double into an int. Since that conversion could cause the loss of information, the compiler won't do it and will complain. Just like when we're learning about types in assignment statements, we could put a typecast to force the conversion. Again, if you think of passing an argument into a parameter, kind of like an assignment statement, this is behaving exactly the way we would expect.
This is because Java is a strongly typed language, and the compiler is protecting us from accidentally losing information.
In our earlier example, we did pass information into our method. The parameter is an integer that is the number of rolls we'd expect for each side of the dice if they each occurred the same number of times. The method uses that value to compute how far each value is from the expected value so it can print the results. So in the call, we can see that the argument is expected count, and it gets stored into the parameter named expected, and that value will be used in our calculation of distance. If you want to pass multiple pieces of information into a method, you can declare multiple parameters by separating their declarations with commas. Here, I have declared a method that takes two integer parameters, x and y, and then prints out their values. When you call a method with multiple parameters, you comma separate the arguments, and they are passed into the parameters in the order you list them. So this call on foo will put the 5 into the x and the 2 into the y, so the output generated will look like this. All of the methods we've talked about so far just do something for us, but we could also make them calculate something and give it back to the code that called them. In this example, notice that the word int precedes the name of the method. That is called its return type, and it means that the call on the method will evaluate to an integer. All of the previous examples had a return type of void because they didn't return any information. In a method that has a non-void return value, we use the return statement to specify the value that should be given to the caller. The return statement also stops the execution of the method, and the JVM will jump back to where the method was called. This method essentially calculates the absolute value of the argument passed into it. If the value is positive, that value is returned. Otherwise, meaning the value is 0 or negative, the opposite of the value is returned. Let's step through these examples.
Be the machine.
When this assignment statement runs, the JVM will evaluate the right-hand side. That will make it call our method, passing a 42 into x. The if condition will be true, so it will execute return x, which is holding 42. That will cause the method to terminate, and the call on the method will evaluate to 42, and that will be stored into P. Similarly, when this assignment statement runs, -3 will be passed into x. Now x is not greater than 0, so we skip the block of the if statement. Then it executes return -1 times x. Since x holds -3, that will return 3. The method will stop executing, and the call on the method will evaluate to 3, and that is what will be stored into P.
It's important to remember that the return statement does two things. First, it lets you specify the value that the call on the method should evaluate to. And second, it stops the execution of the method.
So, a method is a named block of code that we can call from elsewhere. The declaration always looks like this. For modifiers, we've seen public and static, but for now, just ignore these. Return type, the type that the call of the method will evaluate to. If no information is to be passed back, this will be void. The name of the method, and then a list of variable declarations defining the parameters of the method in parentheses.